So when you are using precision and recall in general, for whether we are calculating precision or recall, or based on precision recall, F measure, mean average precision, or E measure, the use of precision and recall has their own problem. Like for instance, what if there is no relevant documents in the corpus? What if no relevant documents are retrieved? In such a case, we can't measure the performance of the system, because if you are dividing by zero number of relevant documents, we can't get the recallability of the system. If no relevant documents are retrieved, it looks like the precision 0. So we need also an alternate measurement that can see, like recall, the reverse of recall, the reverse of precision. Recall is measuring how many of the relevant documents in our corpus are retrieved. If you go for instance, miss, how many of the relevant documents are missed? We can calculate how many of the relevant documents are not retrieved out of the expected relevant document. That will give us how many relevant documents are missed by the system. We can also go for the opposite of precision. Precision is trying to measure how many of the relevant documents are relevant out of the retrieved documents. If you go for measuring noise, you are trying to measure how many of the irrelevant, how many of the retrieved documents are irrelevant. Irrelevant documents retrieved over retrieved will give you noise. So in the meantime, what are the noisy documents that are retrieved by the IR system will give you an information how to improve the effectiveness of the system. Also, we can measure the fallout. Fallout means how many of the irrelevant documents available in the corpus are retrieved by the system. That means how many of the irrelevant documents available in our corpus for that query are retrieved by the system. So how many times our system is falling? In such a way, sometimes if we are unable to get, using recall and the precision, the effectiveness of the system, we can go for the reverse of recall and the precision. Rather than concentrating on relevant, we can concentrate on the irrelevant. If no relevant documents are available in the corpus for the given query, we can measure out of the irrelevant documents within the query, how many of them are retrieved for the query. Out of the available irrelevant documents in the corpus, how many of the irrelevant documents are retrieved for the query will give you us the fallout rather than the recall. So, but mostly anyway, since we are designing a system for retrieving relevant documents from the corpus, frequently we are using recall and the precision. But once you design the system and make it available for the globe, for instance, unless and otherwise we have a connection to retrieve, to index as much documents as possible that are published within the world. It's very difficult for the system to treat the globe, the world in general. Nowadays, Google is known as the best search engine because it is frequently indexing whatever new documents that are published by the world. And then it's very fast in searching and retrieving for any user's query. And always there is relevant documents that are retrieved by the Google for any user's query. So we can measure effectiveness by using different angles. The other issue is related to query itself. On the one hand, what kind of query the information retrieval system is expected to handle. On the other hand, users are searching for relevant document without knowing what's available with the search engine. Now we are searching for relevant document, but we don't know what's available and what's not available with Google. So our search is what? We are blindly searching for something. If the system is able to optimize our search internally and move our query to those relevant documents available with the search engine, it can bring for us as much relevant documents as possible. Like, how can we make the system? I'm searching for Ethiopia. If the queries are if the documents are available with Abyssinia, how can the search engine helps me while I'm searching in Ethiopia to retrieve documents that are written using Abyssinia? Still, we are expecting from the system to help us in optimizing our queries such that we can get as much as possible relevant document that helps the users to satisfy their information need. Towards that, we have to also deal with the queries when we are designing an IR system. So at the end of the day, we have to make our information retrieval system as intelligent as possible that can understand what the users need. When users are formulating their queries, on the one hand, it has to guide them what kind of queries they have to formulate. On the other hand, after formulating the query and submit the query for the search engine has to analyze what's available in its collection and then what's given from the users. And then when it is matching the two, it has to measure the relevance of a given document for that query, not only by looking at only the shape of the word, but also by observing the semantic meaning. To what extent the semantic meaning of the document matches with the semantic meaning of the query. That means understanding the impression of the users. That is towards nowadays intelligent information retrieval system design. So we have to also play around query. That means query is basically an expression of the user's information need. Whenever you need something to read, something to refer, then you are immediately giving for the Google your information need by formulating your information need in the form of query. So query is nothing but an expression of the information need of users. The information need of users are presented for the system in the form of queries. Nowadays, we are formulating textually whenever we need to retrieve image, video, audio, and also textual documents. But still the trend is nowadays towards designing text retrieval system, audio information retrieval system, image retrieval system, video retrieval system. Even nowadays, there are attempts towards designing a multilingual information retrieval system, a bilingual information retrieval system. That means we are forming our queries in one language and we are retrieving documents that are written in the same language or in another language. Cross-lingual information retrieval systems are crossing from one language to another language. Our query is in one language, what we retrieve is in another language. Like somebody who is in a region where that much no publication in his or her language, they are trying to search for documents to read. So they have to cross from their language to another language where different documents are available if they know how to read and how to write and how to understand that language. Again, when we come to different forms of documents, image, audio, video, nowadays there are attempts towards multimodal information retrieval system design. Multimodal means designing a system that searches in different document types. My query is in text form, then the system is searching for any types of documents, image document, video document, audio document, or text document. Or my query may be in audio form. The system is searching using that audio query by crossing different modalities of the way documents are written or the way documents are produced. Still, when we are trying to design an R system, we have to give a great emphasis for the user interface. Nowadays, the user interface of most of the search engines are designed to accept user's query in the form of text. But as a matter of fact, nowadays, it has to also accept image queries, video queries, audio queries, such that it has to start searching in whatever type of data that I need, since they are already available in the author's world because of we are living in big data. So our system should be as intelligent as possible to serve our users as per their own interest, not as per our interest as an R system designers and developers, but we have to take into account the user's interest, and the system should be designed as per the user's interest for users' satisfaction. So when we are forming a query, as I said earlier, mostly nowadays, especially for textual information retrieval, even for image retrieval, nowadays search engines are trying to identify relevant document, whether it's image, video, audio, or text, mostly using words. So here also, when we are presenting our query for the system, we have to formulate our queries by using a combination of words. Then from the query, which is formed by using words, the system, whatever it applied for document, it will start applying for the queries also to identify words that are content bearing. That means words that are query content bearing. We have the system has to identify words that are telling us about the query, the intent of the query, the content of the query. So after tokenizing the query, stop word should be removed. If necessary, normalization should be applied. Then stemming is to conflate the words if there is any suffix prefix. Finally, we have a content bearing base words that are matching with the base words in our index file. Then searching will start. Now the issue is, even if our queries are keyword based, but the way we are querying, the system may be using a single word, or sometimes multiple word, sometimes using phrase. Still, the system is accepting them and attempts to search as per the given query. If your query is a single word, if you are just using only information for searching, the system is trying to find what? A document containing information, the word in your query. Accordingly, which documents are relevant? Documents that are containing the query word information. Then is ranking possible? Yes, possible. How the system will rank for that single word query? Depending on the occurrence of the single word in a given document across the document. That means the similarity score is there, and that similarity score can be used for ranking the document. So the relevant documents for a single word queries are documents that are containing that single word query, and ranking is also possible, best matching. Always those documents which are containing frequently the query words are given more emphasis as compared to those documents containing only one or few of the query word. Sometimes you are also asking using phrase queries, like in Google if you give it in quotation mark. You are asking the system to retrieve as it is by taking into account your phrase in the form of query. So given the phrase, it's looking for mostly exact match. So we are expecting the system to give emphasis for information processing for document retrieval. Even the position of the words should be taken into account. Then those documents which are containing the sequence of the words as per the occurrence of those words in our queries, those documents are given more relevance as compared to those documents which are containing the query words randomly. So the documents which is containing the query terms as it is will be given more similarity score and appears at the top of the list. So still the ranking possible, but mostly we are searching in the form of multiple word queries. We are just writing a query which contains multiple words. The word may be common word, the word may be a word which needs normalization, a word which needs stemming, a word which contains numeric values. Still the system accepts and apply text operations to remove any characters that are not part of the content or stop words that are unnecessary for searching. We are asking data mining and intelligent database design. So the system is identifying data mining, intelligent database design. It may ignore end because end is a stop word, common word. Then since the system is applying partial matching, any document that contain at least one of the query term is considered as relevant. But during best matching, which one is given more emphasis? A document which contains either all of the query terms or near to all query terms. But all the relevant document, whether they are containing one term or all term or some of the query term, they are candidates for retrieval. But when they are retrieved, since the systems are applying best matching as per their relevance using the similarity score, they are sorted and ranked, starting from the document which is registering the highest similarity score to the least similarity score. When you are trying to formulate your query, you are using Boolean operators like or, and, not, because the way you are constructing the query by observing your interest, you are trying to design a query that contains, in addition to basic words, content-bearing words, stop words, and also logical operators like and, or, either, neither, nor, including, excluding. Such words are logical operators. In this example, the query is data mining and intelligent database design. And means what? And is not a stop word here. And is a logical operator. It has to be converted into logical operator. So when we are splitting queries, the query should be split into 3 categories as compared to document. In document, we have a content-bearing words if that word is not a common word. But in the case of query, users are using logical operators to connect a phrase with another phrase. In our case, data mining and intelligent database design means what? The user is looking for a document which contains not only data mining, but also intelligent database design. If the user says data mining or intelligent database design, what does that mean? The user is looking for a book or an article which discuss about data mining only, or intelligent database design only, or both data mining and intelligent database design. So within our queries, there are logical operators that are playing the process of connecting the concepts that we are looking for in the retrieval process. So when we are splitting the query, we have to split the query into 3 parts. So mostly whatever we are writing is, we are writing using multiple words, but internally they may contain Boolean logical operators like not, and, or. from your logic knowledge, the meaning of and or not are different. When you are using and connector, you are trying to check whether those connected with ends are true, if both of them are true, otherwise false. So your comparison is tight. But in the case of or, it is relaxed. Because or is true if those two or more objects or concepts or words that are connected through or are true. When it becomes false if both of them are false. In the case of not, it's negation. If something is true, and if there is a not in front of it, the true becomes false. When we look the logical operators from the retrieval side, in our queries, end is available means the users are looking for an article or a document containing both query. The document becomes relevant if the document is containing both query terms. If in our query terms there is end. But if or is used, if I'm asking about information retrieval and information filtering, what I am looking for is a document containing both information retrieval and information filtering. But if I am using information filtering, retrieval, or information filtering, I am looking for an article which contains either information retrieval, information filtering, or both of them. Also, like information retrieval, but not information filtering. You are sometimes trying to qualify with the assumptions that you want to retrieve a document containing information retrieval, excluding information filtering. So in such a case, we can say information retrieval, but not information filtering. That means we are looking for a document which contains information retrieval, but not contain information filtering. So at the end of the day, whatever you are writing is with the use of internally the logical operators. Your intention is expressed in the logical operators. You may explicitly use them, or you are indirectly using some words for expressing your interest. Let's see the meaning of and or using examples. Like the user is searching for computer or server. What the user looks for is a document containing either computer or server only, or both computer and server. What if we add not in bracket computer or server, then not mainframe. So the user is looking for a document containing computer or server. But if the document is containing mainframe, it has to be ignored. So the user is looking only for a document with computer and server discussion, without any mainframe discussion. So the way you are forming the query defines your information need. And then we have to make our IR system understand the user's intention. By understanding the user's intention, the system has to accordingly interpret and use it for retrieval purpose, especially from any query, it has to identify content-bearing words, common words, and logical operators, unlike the document collection. So in the case of query, logical operators are also critical. So in general, whenever we form a query, we are using our natural language. The way we are using natural language depends on the individual who is using that natural language. Because natural language is a means of communication. And that means of communication is determined by the situations where we are living in. The way you are speaking at Gondar is different from the way individuals at Bahar Dar speak, or at Samensha, or at Addis. How can we make our IR system takes into account whatever ways of writing if they are searching in Amharic language? That's why natural language is mostly ambiguous, complex. Like, see, still researchers are challenged by this kind of queries. Campaign finance reforms, including documents that discuss the violation of campaign financing regulations, do not include documents that discuss campaign contribution by the gun and the tobacco industry. There are words that are defining the information need of the user, and there are words that are available in the form of logical operator. There are words that are common or stop words. How can we make the system accordingly identify the words by their category? And then it has to start searching, like including documents that discuss. It's not part of the information need. Including documents that discuss is to explain further when the user is saying campaign finance reform, what that person is looking for. If the document is also containing such and such, since it's part of campaign finance reform, that document should be retrieved. That's what the information need of the user when it is explained in terms of queries. So dealing with this kind of query, unless and otherwise the system is intelligent, it's very difficult for the system. So dealing with this kind of query requires intelligence. That means, like users, the system has to understand also what the users are looking for. The system has to understand the user's interest based on the queries that they formulate. So it has to know the conceptual meaning of not only words, but also phrases within the sentence in general, even part of the sentence. Then accordingly, it has to deal with that. So nowadays, things are moving towards making the information retrieval system as intelligent as possible. So the natural language that we have should be converted into their logical representation. That means the natural language queries should be converted into pseudo-natural language query. How can we convert them? Identifying those words which are defining, or the phrase which is defining the information need of the users, and also the words or a combination of words that are explaining about logical operators, and then is there any words that are negation, that are or, that are end, that are stop word. Then finally, the system has to detect there are negations like do not include, there are or like including documents that discuss. Finally, it has to come up with internally the query should be reformulated in the form of campaign finance reforms or violations of campaign financing regulation and not campaign contribution by the gun and the tobacco industry. Now it's searching for a document containing campaign finance reform or violations of campaign financing regulation, but not, since the document is not required if it contains campaign contribution by the gun and the tobacco industry. So by reformulating, by understanding the query of the users in a pseudo-natural language for intelligently, by understanding the conceptual meaning, then it has to start searching. So when it is searching, what it brings is 1. Campaign finance reform. If a document contains campaign finance reform, it is relevant. If the document contains violations of campaign financing regulation, again it's relevant. If it contains both of them, again it's relevant. But it has to ignore articles or documents that are containing this part, campaign contribution by the gun and the tobacco industry. So whenever users are providing their queries, they are with the assumption of formulating their queries such that in their own intention, they are trying to make clear for the search engine. Unless and otherwise, the search engine further go to the detail and process it. Maybe sometimes what's used for explanation may be included within the search result, which will create a noise for the search engine. So during query, we have to deal with what are the content-bearing terms, what are the logical operators, what are stop word or common words. We have to tell the system within a query what kind of words are logical operators, or what kind of combination of words are logical operators and or not, and what are the words that are stop words or common words. So before identifying stop or common word, it's good to identify logical operators. After identifying logical operators, the remaining common words are what? Common words or stop words. Then the remaining again are content